Hi students, good morning. I hope all of you are keeping well. During the last class, we have discussed about one method in calculus, that is differentiation. So differentiation is the method by which you are measuring the variation in a function with respect to the variations in its own independent variable. We have a differential operator depending upon the independent variable, that is d by dx, d by dy, d by dz, d by dt, like that. And this operator works on or operates on a function. Then you can get the differential of that particular function. So you are measuring the variation of a function with respect to its own independent variable. Then, while you are taking differential of a function, you are breaking that function into smaller, and finally you will get into finally you are getting into a constant. So this is a function, this is a process in which you are breaking a function into smaller pieces. That is the process of differentiation. Each time when you are taking the differential, the function reduces and finally reduces to a constant and then up to 0. Suppose you are having such small functions and you have to add all these to a larger one. That is the just opposite process of differentiation. From a smaller function, you have to extend into a larger one. That process is integration. So integration is the second method in calculus, which is just opposite to differentiation. So integral is an extended summation. Integration is extended summation. So I use the term it is an extended summation. That is why the symbol of integration is an extended S. That we will see. Integral sign is an extended S. And moreover, very similar to your differentiation, integration also to be carried out based on an independent variable. So for each integration, you have to know about which independent variable you are carrying out the process of integration. So integral is also an operator, integral operator. It may be integral dx if you are based on the independent variable x, integral dy, integral dz, integral dt, like that. Very similar to your d by dx, d by dy, d by dz. d by dx, d by dy, all those are differential operators. Integral dx, integral dy, integral dt, all are integral operators. So that is the basics or the basic idea of integration. Integration is just opposite to our differentiation. In differentiation, we are breaking a larger function into smaller pieces, and here in integration, you are adding all these smaller one to get a larger one. So the process of integration that you can easily understand. The method of integration that can be easily understood with a simple example. With a simple example. When we were talking about the graphical method of deriving equations of motion, we have used, especially for the second and especially for second equation of motion, we have used the method area under the velocity time graph is numerically equal to displacement. So how you can find out the area under a particular curve? If it is a straight curve, the curve is the graph is a straight line, whether it is a parallel or a slanting straight line, you can easily find out the area under. If it is a straight line parallel to x-axis, then it is easy to find out using, if it is parallel to x-axis or y-axis, then it can be easily calculated as the area of a rectangle. If it is a slanted straight line, then you can make use that method of dividing this total area into two, one triangular area and a rectangular area, and you can add the two areas so as to find out the total area. That is a method. But when you have a graph which is not a straight line, which is a curve, and that curve is also having some ups and downs, so how you can find out the area of that graph? That leads to the explanation of integration. How you can find out the area under a curve which is not a straight line, which is a curve and having some ups and downs in between the initial point and the final point. So we can go for that area, and from there you can explain the process of integration. Okay. See the diagram in which we are having a graph which is a curve, and you are asked to find out the area under that curve. You are asked to find out the area under that curve. How you can find out the area under that curve? How you can find the area under the curve? Since it is not a straight line, that methods that you have already used are not applicable in this graph. So what we have to do is, you have to, and that you can, in the diagram you can see that dotted area is the total area that to be calculated. And suppose x is taken along x-axis and y, that is the function is taken along y-axis. Suppose this is a graph of a function. X is taken along x-axis and f of x, that is y, is taken along y-axis. And you have to find out the area under the curve. So to find out the total area under the curve, what you are doing is, the total area you are splitting into small strips with area, height y and thickness dx. The thickness of each strip will be as minimum as possible. Why we are taking dx as minimum as possible? Because when you are taking dx as minimum as possible, then when you see the top of that dx, that strip, it will be flat one. When you keep dx as minimum as possible, then that the height, the top side of the strip will be flat. So that crossed area, that means that lined strip, you can consider as a rectangular strip. Suppose dx is more, thickness is more, you can't consider the top surface as a flat one. To make that as a rectangular area or rectangular strip, you are making dx as minimum as possible. But one problem is there, that is, if you are keeping dx as minimum as possible, the number of strips between the initial point, that is x1, and the final point x2 will be more. If dx is, the thickness of each strip is less, minimum, then the number of strips will be maximum. Is it? That is common logic. If you are considering a strip of minimum thickness, then between two fixed points, the number of strips will be maximum. So when you consider dx as minimum as possible with the height y is the y component of that. So you can easily calculate the area of that small strip, that is y into dx, which is equal to f of x into dx, since y is equal to f of x. So the area of a single strip will be f of x into dx. Area of one strip will be f of x into dx. Or you can consider as f of x1 into dx1. The first thickness dx1 you have calculated, and corresponding value of f should be f1 of x or f of x1, whatever may be. So you are considering dx as similar, that means the dx is as minimum as possible, then you are considering that total area is made up of strips of equal thickness. But you can see at the left extreme and the right extreme, the value of y will be different. Is it? So when you are considering the strip area of each strip, dx will remain the same, but y value will be different. So suppose when you are considering the first area in the left extreme point, then corresponding y value will be y1, and the area will be y1 into dx. Next strip will be y2 into dx, y3 into dx, up to. If there are n strips at the right extreme, then that will be yn into dx. Correspondingly, f of x1 dx plus f of x2 dx plus f of x2 x3 dx up to f of xn dx. Okay, to find out the total area, what to do? You have to sum all these areas. See, that method is very tedious one, because you have to consider the area of each strip and you have to sum all those into, for getting the total area of the graph, that is total area under the graph. But when you consider an area y dx in between the left extreme and right extreme, you know the left extreme corresponding x component will be x1, corresponding y component will be y of x1 or f of x1, and the last point is x2, corresponding y value or f of x value will be f of x2, which means as x changes from x1 to x2, left extreme to right extreme, y varies from y of x1 to y of x2. Y varies from y of x1 to y of x2. So x variation is from x1 to x2 and y variation from y of x1 to y of x2. Anyhow, suppose you consider an small strip in between x1 to x2, that is shown in the diagram, with the thickness dx and height y. So its area will be y into dx, and in terms of f of x, that is f of x into dx. And to get the total area, what to do? You have to make the left extreme of dx to x1 and right side of dx to x2. Then what will happen? That strip will enlarge into the total area. Is it? Suppose the left, see, the left line is extending to x1 and the right extreme is going to x2. That is the left extreme to right extreme. Then this dx will include the total area. Are you getting me? So instead of taking different strips and adding all those areas, you can find the area of one strip and you can extend its limits from the required points. Which are the required points? x1 to x2. Then that includes the total area, total required area, and that is the method of integration. That is the method of integration. See, area of a thin strip will be y dx, which is equal to f of x dx. Then the total area will be integral f of x dx. Integral f of x dx. So this is the integral sign. I already told you it is an extended s. So if you are writing an s in the extended way, that is the integral sign. So this integral sign is indicates an extended summation. So you are instead of taking the summation, you are extending the summation from left extreme to right extreme. Okay, so the total area is moving from integral f of x dx. So actually this means you are integrating f of x from where to where? x1 to x2. Integrating f of x from x1 to x2 with respect to dx. You are integrating, listen my words carefully, you are integrating the function f of x with respect to dx from x1 to x2. See, from x1 to x2, which means x1 is the lower limit of integration and x2 is the upper limit of integration. That is the minimum value of x. X can take the minimum value of x1 and x can take the maximum value of x2. That is why we are saying x1 is the lower limit and x2 is the upper limit. So f of x is extending from x1 to x2. Dx is extending from x1 to x2. So f of x dx you are integrating from x1 to x2. So there are two different types of integral. There are two different types of integration. One is definite integral and another is indefinite integral. So for a definite integral, you have a limit. What is the limit? As in this case, it is this is an definite integral. This is a definite integral. Why? Because the integration is defined between two extreme points, lower limits and upper limit. But there are some another examples of integration in which no such limits are given. From where to where you are integrating, that is not provided. Such integration is known as indefinite integral. So there are two types of integration, definite integral and indefinite integral. In definite integral, the limits are defined, and indefinite integral, the limits are not defined. Okay, anyhow, integration is summation. Integration is summation. It's an extended summation. So you can integrate a function with respect to its own independent variable. Here f of x is integrating with respect to dx, and a function which is integrating with another variable is seem to be constant. A function, suppose this is f of y dx, f of y is considered as dx, constant, because you are integrating with the dx. With respect to dx, f of y cannot be integrated, so that f of y can be taken as a constant. Okay, so integration is the process of an extended summation. So, as I already told you, in the case of differentiation, this method of integration is not in your syllabus, but I explained for your convenience only. That is the method of, this is only the method of integration, but we are interested in the general rules in integration, and that general rules you are using in your physics derivations. See, we have just saw the method of integration, the process of integration. So similar to differentiation, similar to the process of differentiation, we have some general rules in integration, and we are more interested in those general rules only. And this method is not our concern. Both the differentiation and integration, the method is not our concern, but for you to understand what is differentiation and integration, that's only I explain the method of integration and differentiation. That is not our concern. Our concern is only that general rules in integration and differentiation, that only we are using in physics derivations. So we have already seen what are the general rules in differentiation. Now we can see what are the different rules in general rules in integration. Okay, so we can go for general rules in integration. Okay, we can go for general rules in integration. We can go for the general rules in integration. The first rule says, similar to your differentiation also, integral x to the power n dx. Integral x to the power n dx. So integral x to the power n dx is equal to x to the power n plus 1 divided by n plus 1. Integral x to the power n dx will be x to the power n plus 1 divided by n plus 1. Second one is integral 1 by x dx, which is equal to log x. Third one is integral sin x. Integral sin x is minus cos x. Integral cos x is sin x. And integral of f of x plus g of x into dx, that is integral of a sum. That is integral f of x dx plus integral g of x dx. Okay. So these are the major general rules that we are using in our physics classes. So integral x to the power n dx will be x to the power n plus 1 divided by n plus 1. Integral 1 by x dx will be log x. Integral sin x will be minus cos x. Integral cos x will be plus sin x. And integral f of x plus g of x dx will be integral f of x dx plus integral g of x dx. And one more general rule that is very common, and that is already we have used in differentiation also. Differential of a constant multiplied by a function. In that sense, you have taken that constant outside the differential and you have k into differential of that function. Similarly, integration also, that is why I not included that is here. Integral of k into f of x dx, where k is a constant. So that will be k into integral f of x dx. That is very similar to that rule in differentiation. Differential of k into f of x dx will be k into differential of f of x. Integral k into f of x dx will be k into integral f of x dx. Okay, so we can make use these general rules for solving some examples. So while discussing that examples, then these general rules will be more clear. Okay, so we can go for some examples. See, the first example is integral 5x cube dx. First example is integral 5x cube dx. So x cube is a function of x. So you are integrating with respect to dx. And 5 is a constant. So the last rule I have explained to you, that can be used there. That is 5 into integral x cube dx. Remember, if there is a constant, that constant can be taken outside the differential or integral operator. If there is a constant, that k can be taken out of the differential or integral operator. So that 5 can be taken out the integral operator. So 5 into integral x cube dx. See, that is according to the first rule, integral x to the power n dx. What is that? X to the power n plus 1 divided by n plus 1. So here it is 5 into x to the power 3 plus 1 divided by 3 plus 1. That is 5x to the power 4 divided by 4. Okay. So that is first example. That is the first example. Then second example is integral 2 by x power 6 dx. 2 by x to the power 6 dx. Again, that 2 is a constant, that 2 can be taken out. Then that will be 2 into integral 1 by x to the power 6 dx. 1 by x to the power 6, you can take it as x to the power minus 6. So that will be 2 into integral x to the power minus 6 dx. So 2 into x to the power minus 6 plus 1 divided by minus 6 plus 1. That is again x to the power n dx. X to the power n dx will be x to the power n plus 1 divided by n plus 1. So that will become 2 into x to the power minus 5 divided by x to the power, 2 into x to the power minus 5 divided by minus 5. So that can be taken as minus 2 by 5 into x to the power minus 5. Is it clear? Then we can go for the third example. I already told you there are two types of integrals, definite integral and indefinite integral. So first two integrals, what do you think? Are they definite or indefinite? They are indefinite integral. Why they are called indefinite integral? Because they are not provided with the limit of integration. They are not provided with the limit of integration. But here in the third, limit of integration is given. That is integral 1 to 3 5x cube dx. Integral 1 to 3 5x cube dx. The same equation same example we have taken, that is very similar to the first example. First example is a example for indefinite integral, but the third one is definite integral because that function is now integrating from 1 to 3. Here lower limit is 1 and the upper limit is 3. Lower limit is 1 and the upper limit is 3. This example is very important, and this kind of examples, this kind of integrals that you are using in our physics derivations, definite integrals. See, that can be taken as 5 into x to the power 3 dx from 1 to 3. So that can be taken as 5 by 4 into x to the power. You know, integral 5x cube dx is 5 into x to the power 4 divided by 4. That you have already done. And what is the change here? Here you have to apply the limits also, or you have to integrate the same function between 1 and 3. So whatever you are getting after integration is known as integral. So you are getting the integrand as 5 by 4 into x to the power 4 within the limit 1, 2, 3. So whatever you are getting after integration, upon that you have to apply the limits. So then you have to keep it that integral within a square bracket and apply the limits on the right. So the right bottom you are expressed 1, which is the lower limit, and the right top you have expressed 3, which is the upper limit. Then how you can apply that? First of all, that variable takes the upper limit minus the variable takes the lower limit. Method is very clearly shown there. So 5 by 4 into x to the power 4 is the integral, and that integral you have to apply lower limit and upper limit. So the variable first takes the upper limit, then minus it acquires the, or it attains the, or it takes the lower limit. So 5 by 4 is just constant that can be taken out, and upper limit is 3. So that will be 3 to the power 4 minus 1 to the power 4, where 3 is the upper limit and 1 is the lower limit. So 5 by 4 into 3 to the power 4. 3 to the power 4 will be 3 into 3 into 3 into 3. So 4 3s are multiplied. So that will be 9 into 9, that is 81. So 81 minus 1 to the power 3. 1 to the power 4 or 1 to the power 3, whatever may be, that is simply 1. So in the bracket you will get 81 minus 1, that is 80. 5 by 4 is multiplied by 80. So that will results in 100. So this 5x cube, when you are integrating indefinitely, then the result is 5 by 4 into x to the power 4. And you are integrating that definitely between 1 to 3, then its value will be 100. Suppose it is integrating from 2 to 3, then what will happen? Lower limit is changing. So 5 by 4 into 3 to the power 4 minus 2 to the power 4. Is it upper limit minus lower limit? Then that will become 81 minus 2 to the power 4 will be 16. So 81 minus 16, then whatever you are getting, that will be the answer. So this is the way in which we are taking definite integral and indefinite integral. Definite integrals and indefinite integrals. See, one more example is there. Fourth one is integral 0 to pi by 2 cos x dx. Here it is trigonometric function and its limit is measured in angles. So which is the variable there, cos x dx. So cos is a function of x and it is integrating with respect to dx. Again, what is integral cos x? Integral cos x is sin x. So sin x is the integral and that should be applied the limit 0 to pi by 2. 0 is the lower limit and pi by 2 is the upper limit. So which is the variable here? X is the variable here. So that x will take the upper limit first. Upper limit is pi by 2. So sin x will become sin pi by 2 minus, now x will take the lower limit, x equal to 0, then minus sin 0. So sin pi by 2 is 1, sin 0 is 0. So 1 minus 0 is equal to 1. Analyze that examples. First two examples are very simple since they are indefinite integrals. So you just integrate and whatever getting according to the rules, that you have to keep like that. But when you are a definite integral, whatever you are getting, on that you have to apply the limits. So the method I told you, the variable only you have to take. That variable takes the upper limit initially minus that variable takes the lower limit. Okay, then whatever you are getting, that you have to keep there. Okay. Now you see the general rules once more. Integral 1 by x dx will be log x. What is the differential of log x? 1 by x. Integral sin x is minus cos x. What is differential of cos x? Minus sin x. Integral of cos x is sin x. Differential of sin x is cos x. What it indicates, what it says? It says integration and differentiation are just opposite processes. I already told you integration and differentiation are just opposite processes. From the general rules also it is very clear. When you are comparing the general rules in integration and differentiation, you will find they are just opposite processes. They are just opposite processes. Okay. So now we are familiar with both the methods of calculus, differentiation and integration. As I already told you, we are not interested in the method, but we are interested in that general rules. And that general rules are used for different the situations in physics derivations. So all of you have to learn those general rules. All of you have to keep in your mind anytime that general rules in integration and differentiation. So we are diverted from the equations of motion. We were deriving the equations of motion, and equations of motion now we have to derive according to the method of calculus. So in deriving equations of motion using calculus, we have to make use either of these general rules in differentiation and integration. Method of calculus means it includes both the differential method and the integral method. So for the next class, you should be thorough with these general rules. I think the method is also clear, and you learn those general results in differentiation and integration. Then only that derivation will be easy for you. That means then it will be easily you can understand. So equations of motion already you are knowing. We have already derived using the method of graph, and now you are having the general rules in differentiation and integration also. So you have to learn those general rules in integration and differentiation, and using those we have to derive the equations of motion. Okay, so that's all for today. Revise both the methods, learn those equations of, general rules, and the next class we will derive the equations of motion using calculus. Okay, so that's for today.